Problem 1. Here you're given a box and whisker graph which shows the results of a test for a math class. And the advantage of a box and whisker plot is that it breaks the data up into quarters. 25% of the data is between the smallest data value and the lower quartile. 25% of the data is in between the lower or first quartile to the median. 25% is in between the median and the upper or third quartile. And 25% is in between the upper quartile to the maximum value. So just remember, for box and whisker plots, it breaks the data up into quarters. So number 1, what was the high score on the test? Well, here, the box and whisker goes all the way out to 102, so here the high score on the test was 102. Problem 2, what percent of the class scored above 72? Well, here 72 is the lower quartile. Remember, the box and whisker gives the smallest data value, the lower or first quartile, the median, the upper or third quartile, and the maximum value. So here this question is asking you what percent of the data scored above, what percent of the class scored above a 72? Well, here, since 72 is the lower quartile, 25% is between 72 and 88, 25% is in between 88 and 96, and 25% is in between 96 and 102. So here, 75% of the data scored above the 72. Or you can think this way, 25% scored below the lower quartile, so that means 100% minus the 25%, or 75% scored above. Number 3, what was the median score on the test? Well, here the median is that middle line in that box, so that's 88. And then number 4, what percent of the class scored in between an 88 and a 96? And that would be 25%. Do you think this test was too hard for the students? And explain. Now, what you're going to have to do in statistics is not only calculate values, but you're also going to have to analyze your results. And here we have this box and whisker plot, and to answer problems 5 and 6, I'm really going to be reading the length of the whiskers of the box and whisker plot and the size of these different sections. Now, we know that there's a student, somebody on this test scored a 38. So you would think, oh, this test must be really difficult. But I'm going to say the opposite is true. Here the median, the middle value, is 88. 25% of the kids scored in between 88 and 96, and 25% of the kids scored in between 96 and 102. So basically 50% of the students were from really the upper 80s, almost a 90, to 102. This student who scored a 38 is making it kind of misleading. You might think, oh boy, there's all sorts of students here who did pretty poorly based on the length of this whisker. But basically 25% of kids scored in between 38 and 72, but 25% of kids scored between 96 and 102. So the same number that's in this lower section is also in this upper section. So there's an equal amount of kids doing extremely well on this test. So I'm going to say no, because the shorter whisker is on the right. What you're going to have to be able to do is read the length of these whiskers and the size of these boxes and think about what the results mean. Here, number 6 says, would you expect the mean to be above or below the median? Well, remember, the mean is just the average. And I'm going to think the mean is going to be less than the median. Now, how come? Well, this student who scored a 38 is really going to drop the average of the class down. But if you think about what this 38 is, and we're going to be learning in class something called an outlier, this 38 really seems to be a number that's so numerically distant from the rest. 75% of kids scored a 72 or above. But I claim that a couple of low scores are going to drop the average down so that the median, the 88, is going to be higher than the mean. So I'm going to say the mean is less than the median because, again, I'm going to say the longer whisker is on the left, because that's going to mean there's going to be some extreme low values for this test score. Most of the kids did extremely well. Median was very, very high. 50% of kids scored over 88, but one or two kids who scored poorly are going to drop the average down. So that's why sometimes when you deal with grades, the median is a lot more important than the mean. Questions 7 through 11 refer to this box and whisker plot, and it shows the amount of time spent per night on homework for a sophomore class at a certain high school during September. So it looks like here 25% of students spent between 0 and 20 minutes on homework, 25% spent in between 20 and 48 minutes, 25% between 48 and 60, and then 25% between 60, which is an hour, and this particular student a little over 3 hours. So what percent of homework, what percent of sophomores, for number 7, spent more than 60 minutes? Well, here, since 60 minutes is the upper quartile, 25% score above the upper quartile. Remember again, box and whisker plots, the advantage is that they break the data up into quarters. Problem 8, what is the range of times that the middle 50%? The middle 50% is basically the box of the box and whisker plot. So 25% scored between the lower quartile and the median, or 25% of the data values are between the lower quartile and the median, and 25% are in between the median and the upper quartile. So here this middle 50% is going to be in between 20 and 60 minutes. How many sophomores do not do homework? Well, I know that the smallest data value is 0. So I know that there's going to be at least one student who didn't do any homework. At least one. Could there be 2 students who did no homework? There could be. The problem with the box and whisker plot is you don't know exactly how many data values are at each given number. So that's why I'm going to answer the question by saying at least one. There could be 2 zeros in this data set. The minimum value, the left whisker, would still go down to 0. So we can't answer 1. I'm going to say at least 1. And then number 10, what percent of sophomores spend less than 20 minutes? Well, 20 minutes is the lower quartile. 25% of the data is less than the lower quartile. So here we're going to say 25%. Number 11, would you expect the mean number of minutes per night, so the average, to be higher or lower than the median? So here again is a question where we're going to be analyzing the box and whisker plot, and we're trying to make a comparison between the mean and the median. In order to do that, again, we're going to be reading the whiskers. Here I know the right whisker is a lot longer than the left whisker. So that means there's going to be a student or 2 on the very high end of minutes spent doing homework. And since there's going to be at least one student doing 190 minutes of homework, that's going to make the average, or the mean, greater than the median. If you have a data set, if I take the numbers 1, 2, and 3 and compare that data set to the numbers 1, 2, and 1,000, this first data set and this second data set both have a median of 2. But here the average of the second, the 1, 2, and 1,000, is going to be a lot higher because this 1,000 is going to increase the average tremendously. It's not going to change the median. The medians are still going to be the same, but the more extreme values you have to the right, so the longer the whisker is to the right, that's going to make the mean greater than the median. So to explain, I'm going to say the right whisker is longer. Questions 12 through 23 refer to these box and whisker plots that compare the amount of homework time with the amount of TV time. So we have two different box and whisker plots. And for number 12, what percent of sophomores, so this is dealing with the same group of sophomores, what percent of sophomores watch TV for at least 15 minutes per night? So here I'm going to go to the TV time box and whisker. Here they're dealing with 15 minutes, so the 15 minutes is the lower quartile. So what percent watch TV for at least? At least in math means bigger than or equal to, so I want to know what percent of the data value is to the right. And remember, 25% is in between the lower quartile and the median, 25% between the median and the upper quartile, and 25% between the upper quartile and the max. So here I'm going to say 75% spend at least 15 minutes per night watching TV. Number 13, what is the third quartile for the TV time? Remember, the third quartile is the same as the upper quartile, so here that's going to be 110 minutes. Number 14, is it more common for a sophomore at this high school to spend, and here we're trying to compare, more than 1 hour on homework or more than 1 hour watching TV? So if I go to the homework, 1 hour is the same as 60 minutes. So here I'm looking for the 60-minute data value, which is right here. So that's the upper quartile for the homework time. So we're dealing with more than 1 hour. So I know that 25% spend more than 1 hour on homework. Now I want to compare that to more than 1 hour watching TV. And watching TV, 60 minutes, is the median. So that means more than 1 hour, more than the median, is going to be 50%. So 50% of students spend more than 1 hour for watching TV. So is it more common for a sophomore to spend more than 1 hour on homework or more than 1 hour on TV? I'm going to say the answer is more than 1 hour on TV, because 50% of students is greater than this 25%. For problems 15 through 23, we have to identify each statement as true, false, or cannot be determined. Number 15, some sophomores did not watch TV that month. Well, here you have to be very, very careful. The data that's given to you compares the homework time per night with TV time. How can we project that for the entire month? I'm going to put down cannot be determined because the question doesn't deal with the specific data. The data is per night. This is per month. Could a student do no homework, or in this case watch no TV one night, but then the next night watch TV? Sure. So I'm going to say cannot be determined. Number 16, the TV box and whisker graph contains more data than the homework graph. You cannot determine the number of data values with box and whisker plots. Remember, the advantage of box and whisker plots is that it breaks the data up into quarters. But the exact number can't be determined. I know, for example, that the maximum TV time is 225. Could that be one student or 3 students? I hope it's just one student, but you can't tell based on just the box and whisker plot. I would need the data itself to be able to answer that question. So 16 cannot be determined. 17, 25% of the sophomores spend between 48 and 60 minutes per night on homework. Okay, so I'm going to go to my homework time. 48 and 60 is the median to the upper quartile range, and we know that that's broken up into quarters. So we're going to say this one is true because 25% of the data is in between the median and the upper quartile. Number 18, 15% of the sophomores did not watch TV that month. Again, you cannot determine that. The advantage of the box and whisker is that it gives you an overall big picture of what's going on. But a lot of times with statistics, the graphs, you sacrifice precision with the overall big picture of the data. Number 19, in general, these sophomores spend more time watching TV than doing homework. See, this is true. We know, for example, 50% of students spend more than 48 minutes per homework, but 50% of students spend more than 60 minutes per TV time. So in general, this is true. The TV data is more varied than the homework data. More varied means spread out more. So the TV time is absolutely more spread out. It has a greater range. Here, the range of the homework time, remember the range is always the maximum minus the minimum. Here is 190 minus 0, or 190. The range for the TV time is 225 minus 0, or 225. So the TV time has greater range. #21, the ratio of sophomores who spend more than 110 minutes per night watching TV. So watching TV more than 110 minutes, we're going to say is 25%. The ratio, that means fraction, of those 25% to those who spend less time. Well, less than 110 minutes per night would be 75%. So here the ratio of 25 to 75 is 1 to 3. So here it says the ratio of the students who spend more than 110 to less than 110 is about 2 to 1. That's false. The ratio is 1 to 3. Problem 22. 225 sophomores watch TV. This one here cannot be determined. You don't know how many total students there are. If they gave you the total, then you could calculate 25% to figure out the number of students in each range. But here we don't know the total, so we cannot answer that question. Finally, 23, twice as many sophomores watch TV for more than 1 hour. So 1 hour of TV time is 50%. Twice as many sophomores watch TV for more than 1 hour than do homework for more than 1 hour. While students who do homework more than 1 hour, here the 1 hour is the upper quartile, so that's 25%. So twice as many watch TV for more than 1 hour than do homework for 1 hour. That's true. 50% is twice 25%. For problem 24, suppose that one family kept track of how many DVDs they rented each month for a 2-year period. The numbers for each month are shown in the table below. Make a box and whisker graph from this data. Okay, so here we're going to enter the data into a list on our calculator, and what I'll do is I'll put the one variable stat test results up on the screen in a moment. And here they are. Remember that I always look at n first, the number of numbers, 24. This one says each month for a 2-year period, so that's That kind of makes sense that there's 24 data values. And then what we're going to do is we're going to go about setting up a stat plot for a box and whisker graph. So in order to do that, we're going to press second and then Y equals to access our stat plots. I'm going to choose plot 1, make sure that plot is on. Remember, the box and whisker plot is that fifth type, or for some of you, the bottom row middle type of graph. Make sure your X list matches the list in which you entered your data. Remember, you access the lists by pressing second and then the numbers 1 through 6. And the way you go about graphing statistics is once you make sure that your plot is on and you have your correct graph selected, you're going to press zoom and then option 9 for zoom stat. Okay, so here is what our box and whisker plot should then look like. And what you can do to find the actual values on the graph is just press the trace button and then use the arrow buttons to move your cursor from the minimum value to the lower quartile. Here it's on the median of 4.5, the upper quartile, and the max. For question 25, refer to the box and whisker graphs below that show the average monthly high temperatures for Milwaukee, Wisconsin, and Honolulu, Hawaii. Well, here we have Milwaukee's box and whisker. Here we have Honolulu's, and we want to compare both cities, and we want to give statistical terms. We want to talk about the range of the data values, the high, the low points, the medians, the quartiles, maybe even some percentages. So here I'm going to start off by saying Milwaukee has a greater range. Milwaukee's range is, well, in this case, 80 minus 26, or 54 degrees, while in Honolulu, the range is 8, because we have 88 minus 80. So basically the range indicates it's one form of consistency. So the temperatures in Hawaii, not surprising, are more consistent than in Wisconsin. Now, as far as some other comparisons we could make, if we just look at the medians themselves, here we have the median of Milwaukee is 57, and we have the median of Honolulu is 84.5. So we can also add by saying in Honolulu, the median high temperature, because that's what we're given here, the monthly average high temperatures, the median high temperature is, well, if we want to compare, because the question says to compare, the median in Honolulu is 84.5 and Milwaukee is 57. So if I subtract those two, it looks like here we're dealing with 25.5 degrees warmer than in Milwaukee. And finally, maybe I'll say something along the lines of the high in Milwaukee, which was 80, is also the low value for Honolulu. I apologize for my writing, but here we're just trying to make comparisons between the two cities.